These are the preview exercises for College Algebra Lesson 26. Last class, we studied the behavior of two new parent functions, 1 over x and 1 over x squared. We can graph many, but not all rational functions, just by doing transformations of one of these two. So remember, both of these parent functions have a vertical asymptote at the value of x that is excluded from the domain. In both of these cases, that value is x equals 0. You can't make x 0, or you would have a 0 denominator. So we have a vertical asymptote at x equals 0 for both of those functions. This one is f of x equals 1 over x, and this one is g of x equals 1 over x squared. So those are two new parent functions that you should be familiar with and know what their graphs look like from memory. In general, how do we find vertical asymptotes for a rational function that is a polynomial over a polynomial, p of x over q of x? We look for places that the denominator is 0, places where q of x, the denominator, equals 0, but the numerator does not equal 0. So here are 3 pictures. We want to identify the equations of the vertical asymptotes in each. This first one has no vertical asymptotes. This one has a vertical asymptote at this dashed pink line. It looks like it happens at x equals 2. The equation of that pink line is x equals 2. And then the third one has 2 vertical asymptotes at -2 and at 2. X equals -2 and x equals 2. Can a graph of a rational function intersect a vertical asymptote? Never. Okay. Vertical asymptotes are places where the function is undefined. Your denominator is 0, which means the function is undefined there. The graph will never touch it. And how do we indicate a vertical asymptote on a graph? A dashed line.